sinusoidal functions, right? We defined the periods and amplitudes of sinusoidal functions. Now, in today's class, we're going to continue with sinusoidal functions. All right. So, and we also introduced, right? Introduced these variations of this. So, like a phase shifts, a vertical shift, and midline, right? And midline. Right. So now let's consider an example about these concepts, right? So you got to write this functions in standard form, right? Y equals identify the values for A, B, C, and D, and then C over B is a phase shift. D is the vertical shift. Midline is Y equals D. All right. So here, if the phase shift is greater than 0, that's displacement, a horizontal displacement to the right. If phase shift C over B is less than 0, it's horizontal displacement to the left. Okay. And if D is greater than 0, it shifts upwards. If D is less than 0, shifts downwards. Right? Okay. All right. Now let's consider this example. Natalie, can you read for us, please?
Yes. Determine the midline, amplitude period, the phase shift, and the vertical shift of the function f(x) equals negative sin 2x plus pi plus 6 over 2.
Okay, very good. All right, thank you. Let's do this one together. All right, solution. Okay, solution. Now, now to do that, to identify all these, what we have to do is we have to write this one in the standard form, right? In the form of sinusoidal functions. So we have f(x) equals, okay, 2, okay, negative sine 2x plus pi plus 6. Now this one equals negative 1/2 sine 2x. Now plus pi equals what? Now we need to write it in what? In this form, right? Minus c, right? Minus c. So now here it becomes a plus pi. Plus pi is the same as what? Minus negative pi. Yes? Does that make sense? All right, you got to be careful. Here's negative, right? So plus 2 pi. Well, or let's just to make it easier, let's just one step use one more step. All right, 2x plus pi, and plus now 6 over 2. Yes?
Dr. Zhang, I just wanted to tell you I was the phone number joined at first.
Okay, got you, Jared. All right,
Okay.
that's okay. All right, so we have this one. Does that make sense here? Negative 1/2 sine 2x plus pi plus 6 over 2, right? So now this one equals what? Negative 1/2. Now sine, now 2x plus pi. Now what we want to do is we want to write it in something like this, right? So a bx minus c, right? Minus c. So now for this one is 2x is good, but here's plus pi. Plus pi is the same as minus what?
That's
Minus
negative
pi. Yes. And then plus what? So 6 over 2, that is 3, right? So now we got exactly the form of the sinusoidal functions. A sine bx minus c plus d. Okay. Now, what do we have? This implies hence what? What is the value for A? Negative 1/2. B equals 2. C, what is C?
C is negative pi.
C is negative pi. It's not pi, all right? So be careful on that. And D is 3. Okay, now of course, all right, of course, then since d equals 3, the midline is what?
Positive 3.
The midline is a function, all right?
Okay.
You have to be careful. The midline is y equals 3. It's a horizontal function,
Okay.
all right? So the midline is not just 3, it's y equals 3. Okay, it's y equals 3, okay? The amplitude
Is it 1/2?
is the absolute value of a, right? So yes, absolute value of a is absolute negative 1/2. It is 1/2, right? The period is
2.
2. No. What is the period? Is what? 2 pi.
2 pi over 2, so pi.
Yeah, 2 pi over absolute value of b. So that's 2 pi over absolute of 2. So that's 2 pi over 2 equals pi, right? Okay. The period, the phase shift. What is the phase shift?
C over B.
Yes. Phase shift is, I believe that is what? C over B, right? C over B is a negative pi over 2, right? Negative pi over 2. Okay, so this is negative, right? Phase shift is negative, so it's horizontal displacement to the left. Yes, to the left. Okay, now the vertical shift is d, right? Is d equals 3. D 3 is positive, so it's moved upwards, right? Moved upwards. Okay. Now, that is basically given this one.
I have a question.
Okay, go ahead.
Is D in the midline, like the vertical shift and the midline, always equal?
Well, here you have to be careful, all right? The
Okay.
vertical shift is a constant, right? It is the amount of shift. It is a quantity, yes? So D equals 3, right? It is D. Now,
Okay.
the middle line, it is a horizontal line, all right?
I'm saying like their amounts, you always equal the same.
Yes, like y equals 3 is a horizontal line. It is always, it's a slope is 0, is y equals what? Y equals 0x plus 3. Now, because it's a horizontal line, this coefficient is 0 times x, right? So
Okay.
um, that's not a constant. It is the middle line is a function. Y equals 3 is a constant function. Yes. Now the vertical shift instead, it is a constant. Does that make sense? Okay. Very good. All right. Or let's just sketch the point. Sketch this if you want to. All right. So we may just do this. All right. We may just do this. Now sketching. Okay. Now, have you guys heard about the software called the GeoGebra? No? Okay, let me just show you something here. GeoGebra. Let me search it. All right, so this is a really interesting software for I believe it is very helpful for this course. All right, you may want to use this one. It's easy for us to visualize any type of function and also doing many interesting stuff. Okay, so let me share my screen again. Zoom. Okay. Sorry. Da, da, da. Okay, so here is the software called GeoGebra. Okay, it is a software here. Okay, now I'm going to, here is the input, all right? So the function, as we know, it is negative 1/2, right? Negative, oh gosh, sorry. And you see this is, sorry. Oh, sorry. I mean, my laptop is not good. It's always adjusting the Okay, what's going on? Okay, well, can I, sorry. If I
So good.
have, okay, so here is negative 1/2, okay, negative 1/2, and then sine. If you input, just input the function, right? Sine of 2x, is that 2x?
Yes.
2x minus what? Minus pi, right? Plus pi,
Plus pi.
plus pi, plus pi, and plus 3, right?
Plus 6 was the original, and then that was all over 2. Oh, I'm sorry. Yeah, I'm sorry. Plus 3.
Okay. Sine. Okay. You see, if you just do that, and it will should give you the graph.
Okay.
Okay, will. Sorry, where is it? Okay. Oh gosh, it showed, but where is it? Come on. Okay.
Try to click on it. That mark it, the equation. There's a circle next to it. The f of x is a circle. Maybe if you click on that.
Okay. Or let me just duplicate this one, maybe. Duplicate. Okay. Now, here you see that, right? And then the midline is basically something. All right, let me just add another one. Here is y equals 3, right? So y equals 3. All right, you can see this is the midline. The midline is simply what?
The
Yeah,
halfway point.
the halfway point. That's called the midline. Did you see this graph? Right? And also from this one, you can also see the period of this one is pi, right? Well, it's from here to here, correct? If this point is pi, well, it didn't show, but it is pi, right? Now you see, this is, okay. You see this vertical shift. Now, let me just put this sine of x. So you will also compare the sine, right? Sine of x function. All right, let's put them together into one. Do you see the difference, right? The sine is going through the origin, 0, 0. Yes? The sine is going through 0, 0. And the amplitude of single sine function is 1, right? The amplitude is 1. But the amplitude of the function we have is 1/2. Did you see? This is 1/2. This is the amplitude is the displacement, well, the maximum value of this absolute value of A is, which is the maximum. Okay. Now, and also you can also see the vertical shift. The vertical shift is 3, right? Now this is the original sine function. If you move it upwards, you got what? You got upwards by 3. By 3. Now you move to this midline goes to 3, right? And that's what we do. Okay. Now okay, let me just change from sine into that function. Okay, so we have this orange curve, which is sine, right? The orange curve is sine, and now let's just change it to negative 1/2. Use step by step. Negative 1/2 sine. Sorry. Okay, well, why is not doing this? Sin. Delete. y equals y equals what? Equals -1/2 to sine okay, here we go. Sine of x. Well, anyway, I here my laptop is not doing well, but you can see the difference if you change it to -1/2 from sine, and you go step by step. All right, by changing the amplitude and changing the value for b, and then for adding c, adding d to this function, right, from y equals sine x. You can see the difference. All right, you can see the difference here. Unfortunately I cannot show you guys quite well here from this one, but anyway, you may play with this calculator, this GeoGebra. You may play with it. All right, and this will gives you the graph. All right, really interesting software. Okay, but it's not required. All right, you can use you may use the calculator and see, but this one may give you a clearer view and something there. Okay, anyway, I'm gonna just okay, stop here. This okay. We are going to do this. All right, we're going to do this. But the midline, as you can see, oh gosh. Okay. Anyway, all right. So here we go. No, I think this one is going to be better. All right, so determine the midline. Okay, well, this is Mustafa, please.
Determine the midline, amplitude, period, the phase shift, shit, and the vertical shift of the function. F of x equals cosine negative x plus pi minus 1.
Yes, that's good. Okay. Could you please go ahead and solve this question for us? Okay, so my fault. As you want. Okay. Okay.
I thought I was laughing at the beginning.
Oh gosh, sorry about it. Okay, well, that's really my fault.
We'll get a revision for next semester.
I cannot help. All right. So did we got this? So A is a positive one. B is -1, right? So that's -1x. So B is -1. C is -pi. All right. So here -x minus -pi. D is -1. So we have the midline y equals -1. Amplitude is 1, period, 2 pi. Phase shift is pi. Vertical shift is -1. Okay. All right. Now let's determine the formula. All right, for this cosine function. All right, for this cosine function, based on the graph given below. All right, based on the graph given below. Now, we are going to say that it is y equals what? A times cosine bx minus c and plus what? D, right? Plus d. This is going to be the function we're interested in, right? Now, how to find this cosine function? How to find this cosine function? Now, what we can do is, or what we can do is, okay, we can do the following using the following steps. All right. Now, the easiest one is firstly to, well, the easiest one is d, right? To determine the value for d. All right. You can do this. Step 1, identify d. The midline, right? Y equals d. So what is the midline for this one?
0.5.
0.5. Y equals 0.5, right? So as you can see, it is the midline. Yes. So here from this graph, we see that it's a D. That implies what? Identify the midline. Okay. For this one, Y equals 0.5. Hence, D equals 0.5. Yes. Next thing is we can identify the period. Can we do that? Okay, step 2. Identify the period. Period is going to be the absolute value of A. Yes? So what is the period?
Isn't A the amplitude?
Yeah, it is amp.
Huh?
A is amplitude. Is it
Oh,
period?
sorry. It's 2 pi over B. Yes. 2 pi over absolute value of B, right? 2 pi over the absolute value of B. Okay? So we have what? The period equals what? So we have 2 pi, right? Now you can see that the period is 2 pi, right? From 2 pi to 4 pi, from 0 to 2 pi, from negative 2 pi to 0. As you can see, we have, sorry, my daughter. Okay, sorry about it. Is what? It is 2 pi, right? Okay. So we have 2 pi over absolute value of B equals 2 pi. And this implies what? The absolute value of B equals what? Equals 1. Okay. So B can be positive or negative 1, right? B can be positive or negative 1. Okay. And identify the period, which is 2 pi, and we got B equal absolute value. Then B can be positive or negative 1, right? So we will leave it there for now. Okay. So then we can do one more step. Step 3. Okay. Step 3 is going to be identify the amplitude. Which is absolute value of A, right? Which is absolute value of A. So what is the amplitude for this example, for this one?
1/2.
It is 1/2. It is 1/2. All right. So as you can, you should, it is going to be what? The maximum here is 1. All right. It is, the minimum is this one, so it's 0 to 1, right? So the difference between the maximum and the minimum is 2a. Well, I should have mentioned this. All right, so it should be somewhere we did before. Okay, when we talked about the amplitude, this amplitude, or especially in this one, as you can see, all right, especially in this one. Now y equals sine of x. All right, as you can see, the amplitude is a red curve, right? It is from -1 to 1. Yes. So when fx equals 2 sine of x, so it's -2 to +2, right? So it is the maximum minus the minimum divided by 2. Okay, so for instance, all right, divided by 2. So for instance, for this one, 2 equals what? 2 minus -2 divided by 2. That is 2. Maximum minus minimum over 2, right? Over 2. That gives us the absolute value of A. Okay, absolute value of A. Sorry about it. We should have done this. Well, that's not. That's something we're going to learn in this one. All right. So, okay. I think this is going to be what we're going to do. Okay. Equals. Identify the amplitude. It is the it equals. Okay, so it equals max minus mean over 2. All right, which equals what? Max is 1, minimum is 0, right? So which is, well, let me do this. All right, this is the general. This is the general. Okay, identify the amplitude. Absolute value A, it equals the maximum minus minimum divided by 2. All right, so then for this example, we have what? We have absolute value of A equals 1 minus 0 over 2. It is 1/2. Yes, it is 1/2. Very good. Now, next thing is we are going to identify the value for C, right? The value for C. Now, to identify the value for C, what we can do is to set the value x, right? Set the value x and let it be 0 and see what we get. Okay, so step 4. Now, at point 0, identify C. All right. Identify C by setting x equals 0. Okay, by setting x equals 0. Now we have what? Y equals, if x equals 0, all right, so it became what? A times cosine of what? Negative C. Yes, because x is 0. All right, so y equals a equals, and plus d, plus what? 0.5. This one equals what? As we can see at point 0 from the graph, this is here, right? This is here. Okay, so therefore this one equals 0. Yes. So this one equals 0. Okay. Okay, let me add another page here. Okay. Add another page. How to do that? Thumbnail. Select. Okay. All right. Add and insert page. Okay, good. All right, so identify C by setting x equal to 0. So we have this one equal to 0, and cosine. Okay, so cosine. So that implies what? A cosine of negative C equals what? Equals negative 1/2, negative 0.5. Yes, so equals negative 0.5. Okay, so now everything. Then we know that the absolute value. This implies the cosine of cosine. If you take the absolute value on both sides, so the absolute value of A cosine of negative C equals the absolute value of negative 0.5. Okay, so this implies cosine absolute value of A times the absolute value of cosine negative C equals what? Equals absolute value of 0.05. Yes, and this means what? Absolute value of A is 0.5. Yes, is 1/2. And times absolute value of cosine of negative C equals absolute value of 0.5 is also 1/2. Yes. Okay. So this means what? This means cosine of negative c, or absolute value, equals equals 1. Yes, equals 1. Okay. Now, all right. So we have this. Now let's just draw. Okay, consider this one. All right, consider this cosine curve. All right, consider this cosine curve and how we can change the cosine curve to that. Cosine curve is from here, right? Cosine curve is from, okay, it looks like this one. Yes, that's about the cosine curve. Right, we draw the 2 period of cosine curve here, sketch, right? So it's 0, and this is, here is pi, here is 2 pi, right? 0, 2, negative pi, and negative 2 pi. Okay, so this is the curve of the cosine. This is cosine. Cosine of x. All right, cosine of x. Now we have known that b, absolute value of b is 1, absolute value of a is 1/2, and let's see how we can change the cosine of x into this curve, right? So, okay, well, it's really better if I have the other computer so that I can show you in this GeoGebra. Oh gosh, it's just not doing well, this one. Let me do this. Let's get in stock here. Okay. Well, all right. C over B. The internet is not stable. Cover. Okay, good. Oh, just 1 second. Okay, console. Okay. Well. Anyway. Okay. I'm gonna just draw. Okay, I'm gonna draw here. All right. So I'm going to just draw here. Okay. That is cosine of x. And the vertical shift, we already found that. Oh gosh, how can we do that? And 1/2. Change this. Okay. All right. You see, this is not showing anything. Okay. Okay. How about that? Let's take a 5 minutes break, and let me got this one down, and we will continue. How about that? Okay. Let's take a 5-minute bathroom break, and we'll come back. 5 minutes. All right. Got this one fixed. That's just horrible. I mean, okay, all right. Okay, well, anyway, I don't think I can fix this one. Sorry about it. I don't think I can finish it anytime soon because this is my, I'm using my Surface Pro. I do not have a mouse. And when I type it, this keyboard always shows up and down, ups and down, and I cannot type it there. It's causing a lot of trouble here. But anyway, I'm just showing, okay, let me just show you here, all right? So I sketched this graph here. Okay, now by sketching this graph, you can see, all right, from this cosine of x, especially at point zero, it is 0, right? So it goes through this 0, 0. But if you see the original, this curve here, this blue curve, it has a minimum extreme value at point 0. Yes? Well, for the cosine of x at point 0, it has what? A maximum extreme value. Yes? So that will implies, all right, that implies that the amplitude value is going to be what? It's going to be negative. Okay, because if you take the negative cosine, negative becomes positive, it becomes what? Something like, I should use a different color though, but no, I don't think so. Can I do that? Open. Okay. Okay. Sorry, I cannot. I should have used a different color. Okay, so that. Okay, so as if I do the all right, so this blue curve is going to be what? A negative cosine x, right? Negative cosine x. And you can see that at point 0, negative cosine x has a minimum extreme value, right? The minimum extreme value, which is close to this one. At point 0, it is local minimum. Yes? It is at the minimum extreme. Okay, so this will implies that my x value, my a value, all right. Okay, so especially here, this implies that a is negative 1/2. All right, because it is negative. Okay, it is negative. Okay. Let me just write on this next page. All right, and on the next page. Okay. I'm going to erase this one.
Is A, you said A is negative 1/2?
Yes. Okay. Now here, since, all right, at point 0, the graph, the function has minimum extreme. Value. So it has a minimum extreme value, which means what? Which means it's going to be similar like the negative cosine is going to be the coefficient of the a is going to be negative. All right, a is going to be negative. All right, so a is negative. It's going to be a reflection of cosine, right? Reflection over the x called x-axis. As you can see, negative cosine is going to have a local minimum at 0. Yes? Okay, so a is negative. Hence, what? A equals negative 1/2. All right, from here. From here. Because absolute value is 1/2, a is negative, so a is negative 1/2. Yes? Okay, a is negative 1/2. Now, then we can just determine the b. All right, b. All right, determine b. Now for b is the period. All right, the period really here, because we're talking about the cosine function, b and c. All right, b can be positive, can be negative. All right, because cosine is an even function. We will simply choose. All right, let's just choose the positive value for b. Okay, now if it is negative, all right, you can just change another value for c, right? So choose another different value for c, which will give you cosine the negative. Well, anyway, since cosine is an even function, we choose b as a positive. We can as a positive value. All right, we choose b as a positive value. Since b is going to be just 1. All right, once b equals 1. So because absolute value equals 1, so we choose a positive one, right? So you may choose negative 1, but because cosine is an even function, so in the end, if you choose a negative 1 instead, then c value will be the negative of the 1 if we choose positive. All right, so because cosine is an even function, we have a freedom, all right, to choose either positive or negative for b, all right, and then we determine the value for c. All right, so we may for now choose b equals 1. We may choose b equals 1. So then the function became a is negative 1/2, b is 1, right? D is 0.0, right? D is what? D is 0.5, right? The horizontal, the midline. All right. So pretty much everything left is just a cosine negative c, right? It's just a c. C is unknown. Hence, the next one is we want to determine the value for c. Do we have any? What is c? C is the vertical or horizontal shift, right? It's a horizontal shift. So now since here is the tricky thing. All right, here is the tricky thing. C actually can be, you know, see, it is a periodic function. All right, it's a periodic function. We may choose different values of C, but we will choose the one that is the simplest. All right. So for this one, we do not have any. We can view it as no shift from zero. Okay, so you can see if you take a reflection, that's negative cosine of x, right? Negative cosine of x, and then if you take 1/2 negative 1/2 cosine x, all right, then it became something else. But really, there is no shift of c. All right, so how can I visualize? If I have the GeoGebra, is going to be much better. Okay, well, anyway, all right. So I think what we can do is starting from here, right? So since, okay, let me just erase this part instead of doing that. Okay, so we can go from here. Okay, I believe this is going to be identify C. Okay, let's put this step 4 here. All right, in the end. Okay, so let's see what we have. This will give us this one. Now, after we identify the value for A and B and also D, right? So we can just say, okay, well, all right, I'm going to clear, right? Since after A, B, and D are identified, we can identify C, right? So is A cosine dx minus C plus D equals what? Equals negative 1/2 cosine of x minus C plus D, which is 0.5, which is 0.5. Now this one is going to be the function. Okay, so at point 0, x equals 0, we have, all right, so negative 1/2 cosine of negative C plus 0.5 equals 0, right? At point 0, we have 0. So this implies my cosine C equals what? Cosine negative C equals simply 1, right? Cosine negative C equals 1. Is that right? So basically, you just okay. Right. Let me just write one more step. So you understand. Okay. So that means negative 1/2. If we plus both sides by this is okay, minus 1 negative 1/2 on both sides. So negative 1/2 cosine of negative C equals what? Negative 0.5, right? So minus 0.5 on both sides. Okay. Plus 0.5 minus 0.5 equals 0 minus 0.5, right? So this one cancel out. Negative 1/2 cosine of negative C equals negative 1/2. Is that right? Let me add another page probably. Okay, sorry. Select. Okay. All right, so this one equals -1/2. Then if we multiply -2 on both sides, we will get what? Hence, -2 times -1/2 cosine of -c equals -2 times -0.5. This implies -2 and -2 cancel out. So cosine of -c equals here, negative cancel out. That's 1. Yes. So now this implies what? C can be equals 0. That is one choice, right? And okay, so C can be 0. C can also be what? It is can be what? If you check the cosine function, right? At 0, it is 1. At any multiple, integer multiples of 2 pi, they're also 1. Right? So here is 1. Here is also 1. -2 pi. Cosine -2 pi is also 1. Cosine 2 pi is also 1. Right? So we can see that s equal to 0 plus minus 2 pi plus minus 4 pi, da, 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 right? So it can be any number, like the multiples of 2 pi. Now, since the cosine function has a period of 2 pi, right? Since cosine function has a period of 2 pi. All right. So we can, for this one, we can just choose the simplest one. Let's say that we just choose 1 and c equals 0. We may select c equals 0. All right. Since if you move like 2 pi, right, it will be exactly the same shape as not moving, right? Because it have period of 2 pi. So moving leftwards or rightwards for 2 pi doesn't change the shape, all right? So we may select c equal to 0, all right? So hence the function is what? Y equals a is -1/2 cosine of x. X c is 0, right? So we can just do here and plus 1/2, right? Plus 1/2. Okay, so that is the graph of this curve. Okay, okay. Sorry about that. This is, we just spent a long time on this one. Okay, but let's review this one. Right? I want to come up with a method. If we have some new problem, we can do it. All right. So let's just go through this one again and come up with a strategy and how to handle this type of questions. All right, so let's do this one together. Okay, so I think the easiest one is step 1. All right, so y equals d. It's pretty easy, right? This is will determine the value of d. Okay, now step 2, identify the period. Well, it is the cosine, right? It is a cosine. So if it is a cosine function, now here is something you have to be careful. Since the sine and the cosine, there is what so-called we learned the co-function, complementary angles, right? So complementary angles, cosine of theta equals sine pi over 2 minus theta. If you remember that, all right, if you remember that. Now, here is a question of choosing whether it is a cosine or sine function, right? Because if you move sine and do a reflection, you can get cosine. They are really closely related, all right? Now, that's one thing you have to be careful is this curve is easier to use cosine or sine. All right, for this one, this already determined as a cosine function, right? So we're talking about the cosine functions now. The midline can be identified here, and the period can be easily identified as well, right? So we can identify that. Now, since it is a cosine, we are asked to do a cosine function, so we may just use, all right, b as a positive number. All right, b as a positive number. The argument is given here. Okay, the argument is given here. It's an even function. So we see we can just choose a positive value, because if it is negative, then we can just cosine is even. So we cosine negative and cosine positive are the same. Yes? Okay, so that's why we can just select the positive one. Okay, let's just the procedures here. Now, step 1, identify the midline, right? The midline. Y equals D. Step 2, identify the period 2 pi over absolute value of B, and find absolute value of B, and then select the positive value. Right, select the positive value, right? Select B as positive. Okay, now step.
All the cases for B is always positive.
Yeah, you can. Well, it's just easier to select. Well, it's not easier. You can't select. You can select a negative value if you want to. All right, but all right, if you select the negative value, then the C value will be a little different. All right, so you may have to be careful on that. All right, we may just select the positive one, all right, in the future. Then step 3. Step 3 is to identify this amplitude, right? That's absolute value A equals what? Max minus mean over 2, right? And depending on for cosine, this is for cosine, right? For cosine, depending on the especially what now for this one, as we can see at point 0, right? For this cosine, it is what has a local, has a minimum x, has a minimum. It's a reflection of cosine, right? So it has a minimum extreme value, right? Since it has a minimum extreme value for cosine at 0.0, it has a maximum extreme value. Yes. So this is here, but as we see in the original function, it has a negative value here, right? Negative. It's a local minimum, right? So the local minimum is depending on the type of extreme values. Near or at the origin. Near at x equal to 0, right? We select determine the sign of A. How to determine A? Okay. How to determine A? Oh gosh, I'm going to add another page then. Okay. This is more than. Okay, just 1 second. Let's put another page. All right. So if it is a minimum extreme value, extreme, choose A as negative, right? Otherwise, choose A as positive, right? Choose A as positive. Okay, so, and then this is our step 3, right? Then step 4. Step 4. Then that's going to be determine the value of C. By identifying the value by identifying what? By identifying the value by identifying the value at x equal to 0. At equal to 0. Okay, so we will have that. All right, this is going to be step 4. All right.
So for C, we just set x equals 0, and we solve for C. We plug in all the other ones. We plug A and D and B for the equation, and we just solve for C.
Yeah, solve C. Here is select the easiest, select the most convenient one. Select the most convenient one. So many cases we have infinitely many C values, right? Because it's a periodic function, right? So select the most convenient value of C. Okay, and then you got the y equals what? A cosine bx minus c plus d. All right. So, oh gosh, that's a long one. Okay. All right. Now let's just go through this one again. All right. So we did this one at A, B, C, and D. All right. Let's solve another example. Okay. So okay, instead of sine, let's still say cosine. Still say cosine. All right. So let's do this one. How do you think? So determine the formula for this one, cosine function in this one. All right. So solution here. What is the midline?
That'd be 2.
Yeah,
Y equals 2.
Y equal to 2 is the midline. This implies D equals 2, right? So then, what is the period for this one?
2 pi.
The period is 2 pi, right? The period is 2 pi. That implies 2 pi over absolute value of B equals 2 pi. This implies that equals 1. Now we select the positive one, right? B equals, select B as 1, right? Select B as 1. Okay. So, and then we want to make sure that the amplitude is what? What is the amplitude for this one?
1.
Is 1, right? Is 1, right? So is 3 minus 1 over 2, right? So which equals 1. So which implies that the absolute value of A equals 1, right? Now, let's consider, well, for this one, it is we may choose, well, at this point, 0, it is not a local minimum or maximum, right? However, what we are saying that is what? That determine near or at, all right? Near or at x equal to 0, all right? So we may say, okay, so here is a what? Here is a maximum, right? Here is a maximum. Let's say that, well, you can also say that this is negative, all right? But you just choose one of them, all right? Let's say that here is the maximum, all right? So we see there is a maximum extreme value, extreme at x equals what? Pi over 2. Yes. At pi over 2. We will set what? Since it's a maximum, we select is a maximum extreme. So it's otherwise, right? So we choose A as positive, correct? So A equals what? We select A as 1. Yes. We select A as 1. Good. Does that make sense here? Step 1, step 2, step 3. And step 4 here, at point 0, we have, okay, y equals a cosine bx minus c plus d, right? Equals what? A is 1, right? B is 1, but at point x equal to 0, so B times 0 is 0, right? Cosine of negative c plus d. D equals what? D equals 2. Yes?
Yep.
Well, sorry. I think it's better to set as the extreme value instead of 0.0, because 0 it can be taking multiple values. All right. Let me just change this one. Point and add or near. Add x0 or near. For the x at the chosen. Okay. At the chosen. Okay. Sorry here. At the chosen extreme value. Chosen extreme value location in step 3. Okay, this is better. All right, so this is better. I believe. Look, identify the value at the chosen extreme value. Well, is that good or not? Okay. Well,
Can you
just
just write chosen extreme value of x?
well,
That'd be better.
no. Well, let's just say x equal to 0. I think this should be good. At x equals 0, because at equal to 0, it will just give us the c, right? It will just give us c. So okay. Anyway, so cosine negative c plus 2 equals what? Equals 2, right? Is that right? So at point 0, the value of function equal to 2, right? So y of 0 is cosine negative c plus 2, right? Because d equals to b equals 1. Okay, let me just rewrite this one. Okay. We'll put it here. We have plus d equals, all right, equals, a is what? A is 1, right? So a is 1, right? We choose a equals 1. So it's cosine of bx. B is 1, right? 1 times 0 minus c, right? And plus d is 2 equals what? We know that this one equals 2, right? So this implies that the cosine of negative c plus 2 equals 2. That means cosine of negative c equals 0. That's cosine of negative c equals 0. So what is the value for c? Since cosine negative c equals to 0, so c,
0.
no, cosine 0 equals 1, right? Cosine 0 equals 1. If you remember that graph of sine and cosine. Okay, so it's in chapter 1. Be careful. Now, for the second, right? Cosine 0 is the x coordinate. Yes. So cosine of 0 equals 1. Or here, okay, let me just show you. Here we learned for cosine function. This is sine, right? Sine of 0 is 0, But for cosine here, cosine of 0 is 1. Yes? Cosine 0 is 1. But cosine pi over 2 equals 0. Yes? Cosine pi over 2 equals 0. Okay? So, and it repeats, right? It repeats. Pi over 2 is 0. And so on, right? Pi over 3 pi over 2 is 0, and so on. So we will choose. This means, where's that? Okay, so C equals pi over 2 plus minus pi over 2 plus minus 3 pi over 2 and so on. Okay, and so on. Okay, so we may select C equals pi over 2. Pi over 2 be divided by 1 is moving positive. Yes, we select C equals pi over 2. Okay, select a C equals pi over 2. And this one is also, you can see, all right, so this is just not just selecting pi over 2. It's because pi over 2 is also good, right? So it's a cosine function here. Cosine function is moving, as you can see, right? So if you move this cosine function curve to the right for pi over 2, it will be good with this one, right? So cosine function is usually centered at 0, right? At 0. So if you move this cosine curve to the right, right, to the right for something like this, right? So it will be goes along with this one. So that's why the phase shift can be what? Made to be pi over 2. Yes? Okay. So C is pi over 2. Now, therefore, hence the function is what? Y equals cosine of x minus pi over 2 and plus what? D. D is 2. Now, of course, this is using the cosine, right? We discussed the cosine. And then probably in the next class, we will talk about sine. All right. So sine and cosine, actually, they are, now after you got cosine, you can determine the sine, right? And sine, because you have this co-function identities, right? And you can get that. Okay. But in the next class, we will talk about the sine functions. Okay. All right. I think that's already time, and we'll stop here, and we'll see you in the next class. Okay.
All right. Awesome.
Thank you.